Take a long, hard look at this map. It's the one you saw in your third-grade classroom, the one that hangs in government offices, and the one you likely have in your head right now. It defines how you perceive the world. But there is a massive secret your geography teacher never mentioned. This map is fundamentally, mathematically, and historically lying to you. Look at Greenland. It looks like a massive, icy titan, nearly the size of Africa. But watch what happens when we move it. As we slide Greenland toward the equator, it begins to shrink. In reality, Africa is 14 times larger than Greenland. You could fit Greenland inside Africa 14 times and still have room for the entire United States. Today, we're exposing the 450-year-old navigation hack that distorted your reality and shaped your subconscious view of power. To understand why every world map you've ever seen is, in some way, a lie, we have to look at the fundamental geometry of our planet. The Earth is a three-dimensional sphere, or to be more precise, an oblate spheroid, slightly wider at the equator than it is from pole to pole. A map, by its very nature, is a two-dimensional flat surface. Herein lies the central, unsolvable problem of cartography. It is mathematically impossible to perfectly represent the surface of a sphere on a flat plane without introducing some form of distortion, stretching, tearing, or compressing parts of the image. Think of it like this. Imagine you take an orange and meticulously draw the continents on its skin. Now try to peel that orange in one piece and press the skin perfectly flat on a table. What happens? The skin rips and breaks apart, leaving gaps. You can't make it lie flat without ruining the picture. To avoid those unsightly rips and create a continuous image, mapmakers are forced to fill in the gaps by stretching the image, particularly in certain areas. This stretching is the source of the distortion. In 1569, a brilliant Flemish cartographer named Gerardus Mercator devised an elegant solution to this age-old problem. But his goal was never to create a geographically accurate picture of the world. He wasn't trying to show the true size of nations. He was building a practical tool for sailors. In the age of discovery, ships needed a reliable way to navigate across vast, uncharted oceans using straight lines, or rhumb lines. Mercator's genius was to systematically stretch the world vertically as he moved away from the equator, precisely matching the horizontal stretching that naturally occurs when you unroll a globe. This meant that any straight line drawn on his map was a line of constant compass bearing. It was a revolutionary hack for 16th century navigation, but it came with a massive trade-off. The further you move from the equator toward the poles, the more the scale explodes out of proportion. This distortion makes land masses near the poles appear far larger than they actually are, creating the familiar but misleading image of the world we see so often today. The Mercator projection creates some serious distortions, creating what we might call victims of a cartographic stretch. Let's start with the most prominent example, Russia. On a standard map, it appears as a colossal landmass, seemingly consuming the entire northern hemisphere. This visual dominance is a powerful illusion, shaping our subconscious perception of global power and influence simply through its sheer exaggerated size. But watch what happens when we correct for this distortion. If you drag Russia down to the equator, its true scale is revealed. It's still the largest country on Earth by a significant margin, but it's no longer a world-ending giant. Suddenly, it looks much more comparable to the continent of Africa, its familiar, intimidating shape shrinking to a more realistic proportion. Next, let's talk about the Africa multi-tool effect, which highlights the continent's true vastness. Africa covers 30 million square kilometers, a figure so large it's hard to comprehend. On your map, it might look similar in size to North America, but this is a profound understatement. In reality, you can fit the entire United States, China, India, Japan, Mexico, and almost all of Western Europe inside Africa's borders simultaneously, with room to spare. This single fact completely reframes our understanding of the continent's scale. The distortion also creates misleading rivalries, like Alaska versus Brazil. On a Mercator map, Alaska, thanks to its high latitude, looks nearly as large as the entire contiguous United States. It appears as a frozen behemoth, dwarfing states like Texas. In reality, it's only 1/5 the size of the lower 48. Now for the real shocker, Brazil is actually larger than the contiguous United States. But because it sits near the equator where the Mercator projection is most accurate, the map effectively crushes it down. This makes it look significantly smaller than its northern neighbors, robbing it of its true geographic stature on the world stage. And finally, what about Antarctica? The Mercator map commits its most absurd distortion here. It takes a roughly circular continent and stretches it into an impossibly long bar of white pixels that looks like it could wrap around the entire planet. It's a total illusion, a phantom continent at the bottom of the world. So, a map is just a map, right? A simple tool for getting from A to B. But what if the map you've been looking at your entire life has been quietly shaping your perception of the world? Why does this matter? Because in the human brain, size is subconsciously linked to power, wealth, and importance. It's a cognitive shortcut we all use. For centuries, the most common map, the Mercator projection, has put Europe, and later North America, not just in the dead center, but at a massive, exaggerated scale. Greenland, for instance, appears to be the same size as Africa, when in reality, Africa is 14 times larger. This isn't a simple mistake. It's a feature of the map that has profound consequences. This is what experts call cartographic imperialism. The idea that maps can be tools of power, reinforcing a specific Eurocentric worldview by literally inflating the importance of certain regions while diminishing others. When we consistently see the global south, Africa, South America, India, as small and seemingly insignificant on a map, it subtly influences our geopolitics, our economic assumptions, and our very sense of history. It creates an implicit bias that can affect everything from foreign policy decisions to where we choose to travel. And it's not just about size. Even the north-up orientation we take for granted is a relatively recent convention. It's a choice, not a rule of physics. In the past, many cultures, particularly in the Christian world, put east at the top, toward the rising sun and the Garden of Eden. That's why we use the word orientation, from orient, meaning east. Islamic cartographers often placed south at the top, facing Mecca. The decision to universally adopt a north-up orientation was a political one, solidifying the dominance of the Northern Hemisphere powers who were, at the time, charting and colonizing the globe. You might think this is all ancient history, but you're interacting with this 16th century worldview every single day. Even today, your phone uses a version of this map. Google Maps, Apple Maps, and most other digital navigation tools use a projection called Web Mercator. Why? Because for all its global distortions, it has one key advantage for modern tech. It preserves local angles. This makes it the only way to keep city streets looking like perfect right-angled squares when you zoom in for GPS navigation. It's a practical choice for local use, but it means that every time you zoom out to see the world, you are seeing that same old, distorted, imperial perspective. We are still living in Mercator's world, whether we like it or not. But wait, it's not just the land that's distorted. Let's talk about the blue parts of our map, the oceans. On a Mercator map, the Atlantic Ocean looks manageable, a pond between two continents, while the Pacific looks like a vast, empty border on the edges of the world. This is a profound misrepresentation. In reality, the Pacific Ocean is so incomprehensibly large that it is wider than all the land masses on Earth combined. You could fit every continent into the Pacific and still have room to spare. Let's do a quick comparison that shocks most people: Australia. On a standard Mercator map, Australia looks like a medium-sized island tucked away near the bottom of the world. But this is a cartographic illusion. If you could pick up Australia and move it over Europe, you'd see that it covers almost the entire continent. The distance from Perth in the west to Sydney in the east is roughly the same as the distance from London to Istanbul. Yet because of its position on the map, we've been conditioned to see it as down there, and by extension, small. This mental scaling affects our perception of its significance on the world stage. And then, there's the ultimate symbol of our map's limitations. Point Nemo, the oceanic pole of inaccessibility. It's a specific point in the South Pacific so far from land in any direction that the closest humans to it are often the astronauts orbiting 400 kilometers above on the International Space Station. Our land-centric maps treat these vast, empty spaces as secondary to the continents, as mere filler, but they represent over 70% of our planet's surface. When we distort the land, we're also distorting our understanding of the true isolation, the immense scale, and the critical importance of our oceans. We're not just living on a world of countries, we're living on a water world, a complex and interconnected system that no flat map has ever truly captured. Is there a better way? Yes, but every map is a compromise. The Gall-Peters projection shows countries at their true size, but it makes them look stretched and tall. Many people hate how it looks because we've been conditioned for 400 years to love the Mercator lie. National Geographic uses the Winkel-Triple projection, which balances size and shape, creating a more rounded look that is much more honest. And then there is the orthograph from Japan, arguably the most accurate flat map ever made. It can be folded into a globe or tiled endlessly without losing the correct proportions of the continents. It looks strange to us, but that is what the world actually looks like when you stop lying to yourself. The next time you look at a map, remember, you're looking at a 450-year-old navigation tool, not a picture of reality. The world is much bigger, much more connected, and much more interesting than a flat piece of paper suggests. If this changed your perspective, hit the like button and subscribe. Tell us in the comments, which country's real size shocked you the most? Thanks for watching and stay curious.